Hi and welcome to E-ZTutoring. Today we're going to cover how you can solve radical equations when you have two radicals over there. Now in order to do this, I do recommend you are familiar with solving radical equations with just one radical. If you are not, be sure to check out my video on that. If you are, then you are good to go. So in order to solve this, we are going to follow a very similar procedure of steps here. Normally we wanted to isolate the square root, but now we have two square roots, so which one do we isolate? Truth is, it doesn't matter. As long as you isolate just one of them, then you will be fine. So let's go ahead and isolate this one. So we get radical x minus 6 equals 3 plus radical x. And just like normal, when there's only one radical, you know that at this step, all you would do is simply square both sides to get rid of your radical. So we square this side, and that gets rid of our radical. And of course, if we square the left side, we have to square the right side. Now we're left with just x minus 6. And 3 plus root x squared is really just 3 plus root x times 3 plus root x. So we have to FOIL this. Now, do not tell me that this is equal to 9 plus x. Do not distribute that 2 to each one. You're only ever allowed to do that when you have multiplication or division, not addition or subtraction. All right, so we FOIL this. We get 9. Then we get 3 root x. Then we get 3 root x. Then we get x. Because square root times square root of the same thing, square roots cancel out. All right, so at this point, different problems may have different steps. For the most part, the majority will be the same. And what we want to notice over here is that we have root x and x. Makes life a little difficult having both of those things. So if you look closely at the equation, you will actually notice that you have positive x and positive x, which means you can cancel out the x's. We just subtract x on both sides, and boom, we have no more x's, and we only have square root of x. So when we have only square root of x, that makes solving this equation a lot easier. So we have negative 6 equals 9 plus 3 root x plus 3 root x will give us 6 root x. And from here, we just have to solve an equation with just one radical, which we already know how to do. You just isolate the radical. So we subtract 9 on both sides. Negative 15 equals 6 root x. Divide by 6 on both sides. Root x equals, do I have room? Negative 15 over 6. Now, whenever you have isolated your radical, all you want to do is square both sides. The square root will cancel out with the square. We'll be left with just x. And when we square the left side, a negative squared becomes positive. And since we have division in there, we can actually distribute this power to each one. And we will get 225 over 16. Both the top and bottom are divisible by... What are these divisible by? Oh, I'm sorry. I meant to put 36, not 16. So they're both divisible by 9, which will give us 25 over 4. So x is equal to 25 over 4. Now, whenever you have equations with radicals, you're squaring radicals, and a radical could be equal to a plus or minus of a number. So whenever you're doing this, it is possible for you to get an extraneous solution, which means it's possible for you to get a solution that does not work. So I always recommend taking your solutions and plugging them into the original equation. 25 over 4 is really, what is that? 6.25. So if we go ahead and plug that into the original equation, 6.25 minus 6 is the square root of 0.25 minus square root of 6.25 equals 3. So we have to test this out. Square root of 0.25 is 0.5 minus the square root of 6.25 is just square root of this over square root of this, which is 5 over 2, which is 2.5. And you can see that this gives us -2, which is definitely not equal to 3. So just like that, you can tell whether or not it is a solution. In this case, this x is not a solution, which means we have no solution to this problem. All right, so that is how you do it. If you guys ever want ACT or SAT help, be sure to visit my website, www.e-ztutoring.com. Thank you guys, and have a good day.